Hello everyone, my name is Dominic Ranelli, Vendor Relations Manager of T Equipment. We're glad that you guys can join us today for a great webinar that we have with Fluke to discuss process calibration tools. T Equipment and Fluke, we really hope everyone is staying safe during this coronavirus pandemic. Joining us today from Fluke today is Aaron Woody. Before we turn the presentation over to Aaron, and if in case we're waiting for any late joiners to the webinar, I just have a couple slides about our company I'd like to show you. T Equipment, we've been in business for over 18 years and we're a very large stocking distributor. Our slogan, buy from people, not just the internet, is showcased through our qualified and knowledgeable sales staff who are here to help you and assist you in your needs and solutions. On this slide, as a national and international distributor, we cover the needs of a wide variety of customers listed on the left side. The right side gives you an overview of some of the product and instrument types that we carry. In total, we have over 500,000 products. T Equipment has invested heavily and we continue to invest heavily in making our site a great resource. On the left slide, you can see a filter capability by specifications to help narrow your search down faster when browsing for a product. The right side is a screenshot of our internal portal, which helps our customer and sales staff representatives provide our customers with the best solution and experience possible. We are constantly enhancing our website and internal systems to provide a better experience for our customers. Aaron has over 15 years of experience, 8 of which with Fluke, and we're thankful and appreciative of his time to join us today. Without further ado, it's time to turn over the presentation to Aaron from Fluke.
Good morning, everybody. This is Aaron Woody with Fluke, Sales Application Manager for Process Tools and Calibration. Today, we're going to start by discussing managing calibrations with software and our documenting process calibrators, or DPCs. Like I said, been with Sales Application Manager with Fluke. I've been with Fluke for about 8 years as a territory manager in Houston, where I currently reside, key account manager, and currently the calibration process control subject matter expert. I've had a little over 15 years in the industry within distribution, commercial calibration laboratories, and manufacturer's representation. So I've covered quite a few different areas, primarily focused in the oil and gas and chemical manufacturing spaces. If you are able to snap a picture of that QR code, it'll actually send you my contact information. So a real basic introduction of what does calibration software do? There's a lot of questions we field at Fluke about what exactly are we talking about with calibration software. It really comes down to 3 major points. We want to be able to manage our field calibrators or our test instruments. We want to be able to manage our instruments and loops or our assets. We want to manage our results or our data and be able to perform reporting on those results. So additional benefits behind that, you can create custom calibrations procedures and schedules. The scheduling and due date management can be extremely helpful. Reminders and alerts for the technicians as they log into the systems. The calibration reports that can support regulatory compliance. Reverse traceability, being able to track down a tool. If you have a test instrument that has failed its annual calibration, you can track down all of the assets that that calibrator touched in the last 12 months of since the last calibration. Additionally, there's easy navigation of your data, as well as a way to digitally store and back up that data. So starting with managing the test instruments, an example of the software, version of the software, would give you the ability for inventory and catalog all your calibration test tools. You can monitor that scheduling that you can see very easily to the right of the panel, as well as abilities to make those quick reverse traceability. Moving on to test or managing instrument assets. There's an ability to add all of your calibration assets into the software that would allow you to be able to see multiple tools, or basically configure and catalog all of your assets. Within that, you're able to set up different calibration procedures. So if you have an annual procedure for a set of transmitters, but then a 30-day monthly procedure and a different calibration procedure or different accuracy tolerance, you're able to associate those different procedures with the same asset and store all those procedures within the software and not be reliant on the technicians to be able to understand and have the knowledge of what they would have to calibrate and verify assets to. Managing the calibration data would be any of the test results that are either brought in directly from the calibrator, which we're going to talk about later, or any of the calibration results that are manually entered into the system will be data warehoused safely and very easy to back up, as well as the ability to take this data. You can add supplemental data to it, like operating conditions, checklisting features, visual inspection information, and then produce reporting, which is an example on screen of a standard instrument calibration report, providing the as found, as left data with the pass or fail and standard deviation within those tests. DPCTrack2 is the Fluke version of, or current Fluke version of calibration management software. It's a very light, easy to use product, which will be used throughout the examples in this webinar. It is a single user license product that is installed locally on a machine, allowing interface with two Fluke calibrators that can pass procedures and calibration results back and forth. Those products being the Fluke 754 and the Fluke 729. There is a 60-day trial version of the software available where you're able to install the software, work through it, add a few assets. There are example assets in the system already, and be able to interact with the software, at which time you can expand to a full license version of the software. If your needs include a much larger enterprise set of assets, Fluke also works with several of the larger asset and reliability softwares, including ProCal, V5, Smart Plan Instrumentation, or the SPI, Meridian, and AMS. These programs all have direct connectors to the Fluke hardware and essentially mimic the capability with networking accessibilities to allow multiple users to log into the same site. A lot of times we look at DPCTrack2 as a very light user interface or a entry-level way to become accustomed to the software and then build up as DPCTrack2 databases can be converted over into these other enterprise databases at a later date. So today we're going to do a demo and essentially walk through creation of a test instrument, creation of an asset tag, downloading that information into the Fluke 754, running a calibration on both the 754 and the 729 to give a representation of what that would look like, and then uploading the results back into the software and viewing a calibration record. To create a test instrument, very quickly, on the left ribbon, you would select over to the test instrument section where you would be able to see a listing of all the records using, if you were to view the DPCTrack Explorer listed at the top. What we've done here is select New to create a new asset. This asset, you would select the manufacturer, the model number, and the serial number of the device. The manufacturer and serial number would be some of the most important information, as that is how the software will bond the calibration record back to the device that has been calibrated. You have the ability, if you have an annual certification, to actually import the document. So in this case, if Fluke 754 is being created as the test instrument, we can take the annual certification of that 754 and import that document into the software. So we have further reverse traceability back to where that, the traceability of where that calibrator was calibrated. You can also denote for the technicians what types of devices can and cannot be calibrated by that specific calibrator. And then off to the right side, the annual the frequency of calibration needed. The great thing, not only does it tell you when you need to go calibrate your pressure transmitters, but it also will remind you when you need to send your pressure gauges, when your multifunctions and your temperature calibrators need to be sent off for calibration. After we have entered all the information, we save the record and close out that window. The second window we open is the instrument tag, or the instrument window, or where we would enter the asset. From here, we once again select new. We would create the asset by entering the manufacturer, the model number, the serial number, where it's in service. Now we have a lot more available information than we did with the test instrument, allowing you to put in the department it belongs to, its location, its ID, classifications, what type of specific transmitter it is, whether it's actually a thermocouple transmitter or a pressure switch, and then also link any documents. These could be operating procedures, repair manuals, calibration manuals, anything can be, any kind of PDF document can be uploaded, or doc file can be uploaded and attached and linked to these specific docs. The calibration frequency here would also be noted on how often we want to calibrate, whether it's monthly, annually, daily. Once we've entered that information, the second tab would be calibration points. We would open this up and we would want to add a group. And these test point groups are very important because this is where we actually create the calibration procedure. So here's an example of an initial calibration procedure where we would in detail notate what the input and output would be. So in this case, an input of Celsius at a resolution of 0.1 input resolution, low range being 0, high range being 300, the output type being milliamps with 3 decimal places, low range 4 milliamps, high range 20 milliamps. At this point, we're going to use a stated accuracy of percent of range of 0.25% with no added plus or minus. The stated accuracy can be percent of range, percent of stand, percent of reading, plus or minus. So there's ways to build complex accuracies depending on what your SOP requires. You can also notate how many test points we want, and when we hit the calculate button, it actually will build out the calibration tolerance chart at the bottom of the screen. You can go in and manually edit this if you don't want to auto calculate anything. If you have a non-standard or non-linear type of calibration, you would want to hold. Once we've set up the actual asset calibration, we hit the DPC settings button in the upper right-hand corner. This essentially flips over within the same group to the calibrator settings. So if we're going to utilize a DPC, we would want to set up the DPC. So in this case, start thinking about, okay, I've got my hands on a test tool. How would I integrate this? So in the same capacity, we would want to set the source to thermocouple, turn on loop power, set a delay, type K thermocouple using the internal CJC setting and a normal unit type. We would also want to put the measurement setting in current with all other settings being normal. There are availability to have min max settings, user entered variables. So if we want to capture we want to use the radio to call the control room and say, I'm giving you 100 degrees Celsius. What are you feeding back? You can't measure what the control panel sees 100 yards away, but you can manually enter it if you're using a user entered value selection. So once we've created that task, we've saved that, You can set up multiple groups and set up multiple configurations for different types of procedures you would want to run. After we've saved that, we would select the upload download, which is indicated by a test instrument with 2 arrows. And at this point, we would be in the default download screen. The device would now go to look for a DPC that it's compliant with the system. So in this case, excuse me, we found a Fluke 754 serial number 2868006 on COM port 4 on this computer. Over on the left-hand side, we have decided to refresh our list by calibrations due. So any asset in the database that is past its calibration due date would appear in this left-hand list. As we highlight that, the center section gives us an example of what that actual asset is. We can also search by query or by configuration. If you want to grab every asset in boiler room B, and they have been put in that location within the assets that we set up earlier, it would actually pull down every one of those assets, whether they needed to be calibrated or not. Queries can be as advanced or as simple as you want them to be. Those queries can be created and saved for future use. Here I've selected 3 specific demo instruments that I had created, and you can see it moved all of them over to the far right side, the list of tags to download. The G1, G2, G3, and G4 denote the groupings. So in this case, my 4600 Rosemont pressure transmitter has 4 separate calibration procedures built on attached to that asset. It will pull all 4 of those down into the instrument. We click the initiate download button, and the device will, in the 754 case, you'll have the device will turn on and off as it brings all of the established procedures, created procedures over into the 754. Now shifting over to the 754, we will want to set it up and configure it to connect to the calibrator. So in this case, we're going to do a HART smart temperature calibration. So we would configure the device to look for the HART signal across the milliamp jacks. This would be the basic setup, an example of the basic setup here, where the 754 has the capability of powering the transmitter, measuring the milliamp feedback of the transmitter, providing the 250 ohms of resistance necessary for the digital communication, communicating digitally via HART through the milliamp jacks, and then providing the Type K thermocouple sensor input through the thermocouple jack. So essentially, these 3 connections can do an entire calibration. If we're in a live situation and we need to attach via parallel connection, this would be the difference here. It'd actually plug into the side. So we would want to enable our 24-volt loop power in this case. Press the HART button to connect. One of the biggest things when doing HART communication with 754 is to connect the HART before we start the calibration, because if we can run a calibration, but if we want to be able to make an adjustment digitally, we have to have the HART connected before we start the calibration. So once we've connected, we will get a screen that will show us all the relevant digital information off the device. We can verify that all this looks correct, 0 to 300 degrees. We are on the right asset tag. If the tag, okay, so now that we hit the HART or measure source button again, we move into the calibrator mode. We select how we would want to calibrate. You notice down here, the source is dry well. I'll show that in a slide later, but we're gonna select milliamp measure and source Type K thermocouple. That would be a standard calibration mode. This is more of a way to get it into the calibrator mode, because the auto procedure we downloaded will actually configure the calibrator for us. Once we're in this mode, once we're back in calibration mode, seeing a dual source and measurement screen, this gives us a good idea that we have established, and this is a good point to make sure that we are connected properly. If we are sourcing a type case thermocouple, we are getting a 4 milliamp feedback with a slight error. It's a good indicator that we have established a good loop and we have good feedback, as if we were getting no milliamp response, there would probably be an open, we probably would have an open line somewhere. Selecting F4, more choices until tasks appears in the F1 slot. Once we select that, the list of tasks that we just downloaded will appear in the Calibrator. Usage count indicates how many times that calibration procedure has been run on the Calibrator since download. You can run multiple iterations. You could run the same task multiple times. Say if you did a pressure calibration daily, you downloaded it on Monday, did 5 calibrations, and uploaded the results on Friday. On Friday, you would see usage count equal to 5, indicating that it had been run. There were 5 sets of results for that procedure. We would use the arrow keys to select the procedure we would want to calibrate that matches the tag we're attached to. And at that point, the calibrator would fully configure itself as according to the asset information you uploaded. So right now, it's a very simple 0.25% tolerance, but if you had a more intricate plus or minus % of span, or something that's not a straightforward calculation, it will do the calculation conversion for the pass-fail in the calibrator. If the test strategy is not a simple 3, 5, or 7 up or down, it will say standard or non-standard test strategy here. Once we're done, we will hit continue. We will select auto test to start an automatic test. It will run through the 3 points of calibration, source, and measurement, and find the error. Here we found 2 spots that are outside of our 0.25% of error. They've been flagged with reverse video. The next part, it will show what the tag, serial number, and instrument ID used are. This is where the technician could enter their employee number or their name to denote that they did the calibration. Another note is when we are connected via HART, we have downloaded the tag from the asset through the HART data, and we run the task. The 754 will match the expected tag ID from the task to the imported tag ID from the HART data. If they do not match, it will throw an error, alerting the technician that the tags do not match. This error can be, you can push straight through it and continue the calibration. It's simply a warning to alert that you might possibly have selected the wrong task or be connected to the wrong asset. Since we were outside of spec, we want to do a slight adjustment. So F2 in the post as found screen will allow you to select adjust. At that point, you can select being a temperature transmitter, output, or sensor trim. We're going to select output trim. At this point, we're going to check the output side of the transmitter. We are going to feed it a PVAO, or a digital analog out, of 4 milliamps and then 20 milliamps. And the 754 is able to measure the actual current input or output from the transmitter. Here you can see we're inputting, or we're telling the transmitter to output 4 milliamps, and we're measuring 3.997, a very slight deviation. By hitting fetch and then send, we're grabbing the measured value, attaching it to the trim, sending that trim to the transmitter to make the adjustment. From then we move on to the 20 milliamp stage, where we're able to trim at the 20 milliamp stage. Now going back in, we would select sensor trim. We were not going to use a dry well source, but we'll get to that on the next slide. So we'll select no. At this point, we can do set both trim, or do both trims, high and low, the lower, or we can actually reset the device back to its factory default data. And we mentioned using the output trim. The 754 and 753 in a temperature scenario are actually capable of connecting to HART Scientific or Fluke calibration dry wells and micro baths. So this is, with this added serial cable, we can plug into the side, and that would allow us to drop an actual sensor into the device, heat it up to a certain temperature. The 754 will control the temperature output of the dry bath, or of the micro bath of the dry block, as well as measuring the electrical feedback. So here you can see this is an electrical setup. We are providing a source of negative 23.9 degrees Celsius, and our process variable being read digitally is negative 22.9, a slight variation. Once again, we hit the LRV button to bring it to the 0 degrees Celsius and then trim at exactly 0 degrees Celsius. Once again, here's the upper where we are giving it, we are sourcing exactly 300 degrees Celsius, and we're getting 300.1 degrees on the PV, a very slight modification to trim that. If we had the micro bath or the dry block setup, the 750 source would actually be a physical temperature within the bath that the 754 is controlling. So we can get very, very accurate sensor calibration using that method. Now that we're done, we run the as left feature. It runs the exact same test as the as found, and we're able to see that the calibration is well within the 0.25% tolerance we set. Now, jumping across, we wanted to give a good illustration of what a 729 would do. So in a 729 scenario, we'd obviously be doing pressure. 729 is a documenting, automatic pressure documenting calibrator. So this is a pressure-only version of the 754 DPC. It has a built-in electric pump and electric regulator that allows you to dial in a pressure setting of up to 300 psi, and the device will pump up to that and hold. So, and we can do multi-step 3.5 point checks, and it will step to each level with that regulator and pressure gauge. So here it's a very simple connection to a standard pressure transmitter. The loop power, 250 ohm resistor, HART communication, and milliamp measure can all be done through 2 of these jacks, 2 leads on these jacks, and the pressure connection is a simple pressure hose and fitting from the internal process sensor to the high side pressure port of this transmitter. To do this calibration, we would vent, press the vent button to keep the device vented. We would turn the loop power on and 0 the internal module to ambient air pressure to begin. We would hit the HART button and it would begin polling the digital addresses on the device. You can also turn your loop power on and enable your HART resistor from this menu right here. Once it finds a device, it will continue polling and looking for additional devices in a multi-drop scenario. But once we see address 0 and a point-to-point, we can hit the continue button. It will bring up the HART data where you can review all the HART information similar to what we saw in the 754. We hit the back button to go back to the main menu screen where it will show us the over-under of the measurement, the electrical measurement, and the pressure. By hitting a tab, there's actually a task button on the lower left-hand corner of the keypad on the 729. That will bring us to the automatic task screen. So where we had to go to a soft key in the 754, it's actually a hard tactile button on the 729. At this point, you can do an ad hoc calibration of any of these predefined devices, or in this case, we would want to hit the soft key F2 to go to downloaded tasks. At that point, we would select the task that we had downloaded, and it would auto-configure the calibrator. In this case, my 4600 Rosemont is a 0 to 50 psi, 4 to 20 milliamp pressure transmitter. It is set for a 0.2% accuracy, a 3-step up, then down calibration with an auto settling time of the internal sensor of 5 seconds, meaning it will go to a calibration set point. It will wait 5 seconds to settle, take the reading, and then move on to the next point. At this point, you are also enabled to do a leak test if you have any questions about the integrity of your pressure fitting connections to your device under test. A short automated leak test can be run. So again, I always try to 0 again if there's any kind of movement when it's still vented. We're seeing here that we have a milliamp feedback, so we have a good connection. We run an auto test. It will step up through and start pumping. Here, the set point is 0, so it's going to vent. It's telling me it's not ready. As soon as it is ready, you will see stable and it'll start counting. Once it gets to 5 seconds, it will then increment to the next set point. So here it's at the mid set point. At 5 seconds, it would increment to the 50 PSI set point and begin pumping again. At the same time, it's dynamically calculating the error across that calibration. Once we're done, we're going to give the test point it shot for, the test point, the source pressure it actually achieved at that test point, the measurement, and the error with a nice pass screen here. You'll notice we also, the 729, it's a newer design, we enabled the color screen, so it makes it a little bit easier, a little bit more friendly to the eye to see your results. Once we get done, once again, we in the tag serial number and the user, my name entered here, are auto-populated via the task that we ran. We can make HART adjustments, just like we did with the 754. In this case, we can do a PV0 trim, a milliamp output trim, and then HART trim on the sensor to apply values. The milliamp trim, the pressure 0 trim here, it gives us the actual pressure, and then here's the PV. Once we get the set point down to 0, we're allowed to hit the F3 trim 0. It'll move the PV down, and you can see dynamic in real time that trim, what the digital 0 of the transmitter is. The milliamp output trim is very similar to 754, where we see the PV current and the measured current, and we're allowed to trim using the F1 and F2, and then we can cycle back. The one advantage of the 729 is we can actually pivot back and forth between the 4 and the 20 if we have any doubt that the low side might have moved when we moved the high side. Once we hit the as left button, we go back and we run another auto test. It will run back through the same procedure again. We'll get the results again, and these are even a little bit tighter than they were before. We save the tag serial number and user ID. Now, going back to the software, we've completed multiple calibrations on both tools. We'll connect the 754 back up to the laptop we're using, and we'll select the upload tab instead of the download tab this time. Once again, the computer will find the Fluke 754 on COM port 4. Here we can leave the Who Calibrated blank. We can use the technician ID we entered with every calibration, or we can actually force assign to another person. So depending on how you're set up on what you want the default technician ID to be. There are also a lot of other options we can select as far as when we do a bulk import of calibration records, how we want those to look. The options tab gives you even more options as far as uploading that information. Once we've uploaded that information, it is customary for the 754 and the 729 to ask you to delete the information off of the hardware to prevent you from confusing procedures you've already run. So it's very normal to upload the results and then delete all of the information off the DPC. So when you go back in to download more information, you're starting with a blank slate and you don't confuse what procedures you've done already. It also keeps you from uploading the same results back into the software multiple times and creating duplicate records. So once we've uploaded all the results, we go to the calibration screen where we can look at the calibration information, the test results, and the test instruments. So within here, you can see there are quite a few fields that the calibrator did not capture as far as temperature, relative humidity, certificate numbers, if there was a failure, the reason for the failure, and then other information that would be imported from the instrument tech. You have this ability when you're going back and reviewing the records to add more information about the record, about why it failed or any other test results into this. The checkbox finalized allows you to say when an item is complete, and that is actually controlled by an administrator. So you can give technicians the ability to not be able to finalize calibration records, so they're not put into the permanent record until somebody with authority to review them and okay that they were done and all the data was entered correctly. You can actually check that off. Once we've checked those calibration records and they're all entered, we can view the reports. So by selecting the report dropdown, the calibration dropdown, and the calibration report specs and test points, we can then search for any results completed between certain dates or just hit the preview button. And what it will bring up is a certified calibration report. So within this calibration report, it's going to give all the relevant information about the device. So the tag ID, the description, and when it was calibrated. It's going to give all the device, the asset information, the device model number, manufacturer, serial number, where it's located, any kind of other certificate or SOP data that's associated. Below that, we'll show by group the specific test procedures that were run, the test points, what the results were, and the pass or fail. And then below that, similarly, when the calibration procedures are passed back and forth, the calibrator passes its manufacturer, model, and serial number along with the data. So we went in at first and said it was very important when we, for example, when we put in the Fluke 754 with the serial number, that we make sure we have the serial number of the calibrator in. It matches those three things, and then is in the certification is able to say that the standard used to calibrate this asset was a Fluke 754 serial number. And because you've entered when the last time it was calibrated by either yourself, if you have the capability, or a third-party lab, or Fluke, Fluke's factory can recalibrate these instruments. It's actually going to put that information into the document. So you have full traceability through the actual Fluke calibrator that you used. If the asset, if the information about the test instrument passed with the asset does not match something in the database, it provides a notation that the calibrator used in this calibration was not logged in the database, therefore they don't have any information about its calibration traceability. Similarly, in the back is an instrument master report, which can be run on the instrument itself, which gives a full detail of all the calibration procedures that have been run on the instrument, what calibration procedures are set up, whether they've been run or not, and any reverse traceability on that instrument. The reporting capabilities are quite vast. It's really a matter of just how you want to build the reports up. Here's a pulled-in view of another example, is a calibration worksheet. If you choose to use the calibration software and don't have a DPC or automated calibrator, or are doing a calibration that doesn't require, so like a pH calibration possibly, or a gas analyzer or a gas alarm calibration, you can actually create the asset in the device and then print a calibration worksheet. And you'll notice here, it tells us what our test points on that same 0 to 300 degrees Celsius transmitter are, but it does not actually but it gives us blank spots where we can notate what the actual measurement was. It also gives us the low and high allowable errors for those measurements. So at 0 degrees Celsius, I'm allowed between this 3.96 and 4.04 milliamps. There's a note for the technician to add the as found, and then their as left after adjustment, and fill in temperature, humidity, and sign off on who did it. These paper records can be then brought back to the instrument database in the shop and manually entered back into as a new calibration record. So some of the other additional features of the software, DPCTrack Explorer is a very quick and easy way to view all your data, whether you want to quickly see a tree, a file structure in a tree format that you can see all of your assets, all of your test instruments, all of your calibrations. There's great badge and highlighted visual indicators to help you identify tags that need attention, tags that need calibration. Reminders pop up at every login. So anytime a technician or an administrator logs into the system, a pop-up box will pop up to remind them what things need attention, whether they need to finalize or authorize calibration records, whether they need to go out and do calibrations, or whether their test instruments are past due to have themselves calibrated. Advanced queries allow you to build and pull data from different locations, really dig into your data mining for better fault isolation around, a great example of that would be a customer is looking at the number of times the serial number on an asset changes to indicate, as a good way to indicate how many times they actually have to change the transmitter. And certain manufacturers are being changed more than others in certain services. They could use that to identify maybe that they're having a problem with a certain brand or make of transmitter. Loop records allow you to combine multiple instruments into a complete loop. So if we have a multi-drop loop or multiple assets, a switch that's tied to a control valve, we might want to calibrate those together. You're able to pull those together into loops. Document records, this is what we talked about, importing third-party PDFs, documents, spreadsheets into, so they're very easy to get to, technicians can access those very quickly, and instead of having to go back to another program to find out when your multifunction calibrator was calibrated by that third party, you're able to actually, with one click, bring up that a scanned copy of that calibration certificate. And then calibration groups, we talked about that a little bit, allow you to have multiple procedures on the same asset. So spending a little bit of time extra on the HART side of the device, here's a good example of like the 3 different stages of a HART transmitter. And from the input, the sensor input, the output of the digital primary variable, the range computation, to the output of the primary variable analog out, to the actual conversion to a 4 to 20 milliamp signal. This is the basic setup. The 754 and 729 are unique in their capability of being able to source a temperature or pressure or multiple different sensor inputs, and at the same time be able to run the adjustments on the trims, manage the lower and upper range or change those, run loop tests and output trims, while also being able to digitally see the PV and the PVAO. So where a communicator would only be able to see the digital portion of the transmitter, the 754 can see both the analog and the digital simultaneously. In cases where we have certain transmitters or certain devices that need a deeper dive into the HART, a pure DD communicator, the HART 154 Calibration Assistant is a wireless modem connected to an Android tablet that would allow you to, in this illustration, connect up to a transmitter with a Fluke 754 to provide a deeper dive into the transmitter microprocessor and allow you to run certain device-specific calibration protocols. I can speak to flow meters, especially, that have a lot of specialized calibration procedures that this can be used, and thus the calibration assistant. It is a true HART communicator, drop-in replacement for existing HART communicators, but it is intended, its primary objective was to be an associate to the 729 and 754 in these applications. And once again, an example of the 5 HART or the 5 Fluke devices that are HART compatible. The 754 and 729 are compatible with the documented calibration software and able to communicate directly. The 709H and 710 are capable of doing quite a few of the loop calibration and HART manipulation procedures, but will not save actual test results for upload into the device. And that concludes the presentation from the Fluke side of things. I think we hand it back and ask any questions at this time.
Cool. Aaron, thank you very much. Just want to say thank you for your time today, for everyone for joining us. If anyone does have any questions, please filter them through our chat feature and we'll be able to get those answered for you in a timely manner. Before we go to some questions, I just wanted to let everyone know that we'll post the entire version of this presentation and slide deck on our Interworld Highway YouTube account and on TE Equipment as well. Looks like we're waiting for a couple questions, but I have 1 or 2 for you, Aaron, if you don't mind. What are some of
Sure.
the biggest time savers associated with the calibration software? I know you hit on some of the topics during the slide, but for saving time, what are some of the biggest time savers associated that come with this product?
One of the biggest things with time saving is we're eliminating the pen and paper with this capability. We're allowing the devices to digitally house all the material. We're not having to go back to the shop and write down all the information. If we are in a reverse traceability scenario, so say you do annual calibrations of your flukes and you send them back to a device, and we hear about this all the time, that somebody sends a device back after 12 months to get its annual cert and it fails. It goes OOT, or out of tolerance. Well, they now have to assume, per their internal regulations, that anything that calibrated since the last time it was calibrated is also out of tolerance and it has to be checked again. And that can take weeks to go back through the paper documentation and the filing to find out what devices that touched. With a simple query in DPCTrack, you can look up every single asset that calibrator touched and very quickly go out and reassess their integrity and their reliability with a tool that's has passed calibration.
Gotcha. Cool. Appreciate that information. Can you talk about some of the challenges or maybe the biggest hurdles that someone might have when they're starting out using some software?
Yeah, really the first biggest thing, the part that a lot of customers worry about is the initial startup, the initial startup of getting that database digitized. And there are a lot of ways to do that. There are a lot of capabilities within the software, especially the larger enterprise companies, that all have ways to bring data. If you have any kind of spreadsheets or digitized asset databases, we can actually bring that information directly into the software. The 709H and 710 actually have capabilities to save profiles of transmitters by looking at the HART data, and we can actually dump that to a spreadsheet and then import that as well. And then some of the newest features on some of the enterprise softwares as well, because it tends to be a bigger deal to the plants and the organizations that have massive amounts of assets that would need an enterprise software, that they're actually able to do reverse engineering by doing an ad hoc calibration with the 754. And when it connects and doesn't recognize that asset serial number and tag, it asks you if you would like to create a new asset. So instead of having to type it out into the database first and download it, you're actually able to create the asset in the database as you're importing test results you've already created.
Gotcha. Okay. And I think we just have one more question. Can you talk about if these products are available in bundle packages?
They are. We mentioned the trial software that is available. Anytime a customer buys a documenting calibrator from Fluke, they'll get a flyer. It used to come in a CD, but now we prefer the go to the website to do it these days, to less waste, I guess, a little bit more environmentally friendly. But we ask you to go to the site and download that 60-day trial. Conversely, if you're interested in starting right away without the trial, and you're interested in buying a 754 or 729 to get started, you can buy what we call or bundled kits, meaning you buy a copy of DPCTrack2 with a calibrator, and it comes out to roughly about 50% off of the initial cost of the software. So you can save quite a bit of money by bundling. And I know you guys have done a great job in bundling up our software with all of our hardware, even expanding on what Fluke offers directly to you guys as a distributor. So there's a lot of great options for getting significant savings on starting your software journey when buying a piece of hardware from Fluke.
Gotcha. Great. I don't see any other questions that came in, but just as a reminder to our audience, copies and archive footage of this webinar will be available on TE Equipment, visiting the link included in this PowerPoint, and we'll also email out a version as well. Aaron, just want to thank you and your team at Fluke once again for your time today. Really appreciate the opportunity to join you today, along with our attendees.
Yeah, we Fluke love and appreciate the equipment for hosting this, and hope to do them again in the future.
Great. Thank you very much, everyone, and have a wonderful day. Thank you.